Welcome back, friends. In this lecture, we are going to discuss about L attributed STT example. Okay. So this is our production rule and it is related semantic rule. So before going to mention about this production rule and semantic rule, I just want to rewind what is L attributed STT. So L attributed STT specifies both the synthesized attribute and inherited attribute. So in the synthesized attribute, the value can be evaluated only from the child nodes. But in L attributed SDT, it contains both synthesized and inherited attribute. So this inherited attribute means it will evaluate the value from both the parent and the siblings. Okay. So here we will be having both the synthesized attribute and the inherited attribute for L attributed SDT. So this is the production rule. So here for this example, we will be taking a declarative statement. So int id1, id2, id3. So this is our declarative statement. For this statement only, we are going to derive the L attributed STT. Okay. So the first production rule is D tends to TL. The meaning is a declarative statement tends to T and L. Here L is the inherited attribute and T is the synthesized attribute. The T specifies the type of the value. Okay. L specifies the terminal. So the L specifies the terminal, that is the identifier. Okay. List of identifiers is mentioned by the L. So for this production rule, the related semantic rule is L dot in equal to T dot type. The meaning is the L dot in, this L is an inherited attribute. It takes the value from its siblings, that is T dot type. Okay. So the T is mentioned with the type that is called integer. So here in the second production rule, it is mentioned, the type mentioned as integer. So this related semantic rule is T dot type equal to integer. And the third production rule, T tends to real. So it is mentioned that T dot type equal to real, semantic rule. Then the fourth production rule is L tends to L1 comma ID. Okay. So here this L inherited attribute will be having the value from L dot in, that is this L dot in will be, this value can be achieved or this value can be retrieved from the parent value. Okay, this parent value, that is L dot in. Then this ID, what it mentions is the related semantic rule for this ID is this ID will be added with the type. So add type id dot entry. You have to mention this entry in the symbol table. How the entry is mentioned in the symbol table is id dot entry comma L dot in. So we know that this L dot in definitely will be having the type, okay, from the T. Okay, we'll be having the type from the T. So this identifier value will be mentioned in the symbol table along with its type. Okay, for example, integer id1. Okay, so again, why this semantic rule, why this production rule is given us? So in the previous production rule, we have L tends to L comma id. This L is a recursive function. So again, we have to substitute this L with id in order to complete the production rule. Okay, so now we will see how an unattended parse tree can be constructed for this declarative statement. Okay, so our start symbol is D tends to TL. So we will be starting with the D tends to T and L. Okay, so we need integer type. So, okay, we need the type integer first. So we have to check which production rule will be applicable. So T tends to int, that is applicable. T tends to int. So, and another one thing, kindly understand this. L attributed SDT will be evaluate the value from the depth first search. Okay, from the depth first search. So that from the parent to the child, then for the siblings, then it will be going in the adjacent side also. So T tends to int. Okay, then when you are going for its siblings, so this L. So So this is for cross production rule. T tends to TL. So T can be derived with the type integer. Okay. Now, what is the next thing? So now we got the integer. Okay. So we have to get this identifiers, identifier 1, identifier 2, identifier 3. So 3 identifiers has to be evaluated. So which production rule is applicable, that we have to see. So you can see here L tends to L1 comma ID. So expand this. L tends to L comma ID. Okay. Again, so one ID has been evaluated here. So we need another two IDs. Again, use the same production rule. L tends to L comma ID. And we need another one identifier. So L tends to ID. Okay. So now we have to evaluate this. So for this production rule, T tends to integer. Okay, what is the related semantic rule? T dot type equal to integer. So mention it as T dot type equal to integer. So now what about its siblings? So what is the production rule for this L? So L dot in equal to L dot in equal to T dot type. So it will be taken from the siblings, this T dot type. So what is T dot type? T dot type equal to integer. We're able to understand. So L dot in, the semantic rule is T dot type. So we are taking this T dot type, that sibling, so with this integer. Okay. So T dot type equal to integer. So it is mentioned here. Okay. So next thing is L tends to L comma ID. So this is the production rule. L tends to L comma ID. So what is the related semantic rule for this L dot in? So L dot in equal to L dot in. Okay. So this L dot in is yeah, we know that already this L is an inherited attribute. It can take the value either from the parent or it's from sibling. So in this case, it takes the value from the parent. So L dot in equal to, so this L dot in, that is the parent. So that is equal to integer. Okay. So what is the next semantic rule for this production? Add type of id dot integer comma L dot in. So this id dot integer will be added. So sorry, id dot entry. So we have to mention this id's entry in the symbol table. We have to mention this id's entry in the symbol table along with this L dot in, that is int id. So in the symbol table, so this thing will be evaluated. So int id will be stored in the symbol table. So we have to add this. Okay. Then next, L dot in L tends to L comma ID. So same production rule. So L dot in equal to L dot in, that is the parent node. So it is taken from the parent node, that's L dot in equal to integer. Okay. The same semantic root, add type of id dot entry comma L dot in. So meaning is, so this id dot entry, this value of id will be mentioned with the entry in the symbol table along with the type. Okay. Along with this type. Then next thing is again L tends to ID, this production rule, the same semantic rule, ID dot entry. So now, as we know this L is an inherited attribute, so it will be taking the value from the parent. It will be taking the value from the parent. So int ID will be given the entry. So here int ID, here also int ID, and here also int ID. Okay. So this is an example for L attributed SDT. So now you can see here. So the symbol siblings are mentioned. So how the values is int ID1, ID2, ID3 will be evaluated, will be written as int ID, then int ID, then int ID. So this will be stored in the symbol table. This int ID will be stored, but as per the depth first search concept, so this will be taken from the parent and the child. Parent int ID, int ID, int ID. Okay. So finally D tends to TL, that is int So L in will be containing all this ID1. So the classifications of this identifiers. I hope you have understood this example of L attributed SDT. Thank you.